Hello and welcome everyone to the Learn Analytics and Machine Learning with Red Bull Racing Hands-On Lab. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today we're excited to solve with you the challenge of what makes the best race of all time. If you haven't joined our Slack channel yet, I will provide you with the link and please ask any questions you have there and we'll answer them throughout the session. Helping out, we have Jaren Klusterman, Product Strategy Director for Analytics and Data Science, Andrea Bridge-Landano, Developer Marketing Analyst, Felipe Jaramillo, Principal Developer Marketing Manager, and Dan Gainey, Senior Cloud Trial Specialist. We also encourage you to sign up for your free cloud trial to follow along with each lab step. And finally, you will also have the opportunity to participate in a short quiz on the material covered in today's lab. Upon completing the quiz, you'll receive a Developer Masterclass badge that you can share to your social media, recognizing your commitment and earned expertise. Today's lab will be presented by Olivier Perard, Master Principal Cloud Architect. So without further ado, I will turn it over to Olivier.
Hello, everyone. Okay. My name is Olivier Perard. I'm working on the Developer Cloud Evangelist team. Okay, today I will be the presenter, okay, of this session, and you could follow each step of this workshop. I will execute each step in live, and if you have some problem, you can send your question to the Slack channel, where some Oracle expert will drive you to resolve your questions. Okay, in the Slack channel, you have the link of the Slack channel. You have the same information on the chat of the Zoom. Okay, you can access to this Slack channel. You need to register to this whole Hands-On Labs 01, 27, 22, and you can send all your questions. Okay, if you have some problem in the provisioning step, okay, you can send your questions, and we have some experts, okay, in this channel to help you to resolve all your problems. Okay, you receive an email with this link, okay, to create your free trial account, okay. And this free trial account, you have been whitelisted. Normally, it's not necessary to put your credit card, but if you have not been whitelisted, okay, you need to put a credit card, but you have a free trial during the 1 month. Okay, you can use this credit to deploy some services. And today, we will deploy 2 services on this Console Labs. Okay, we will test two services, Autonomous Database and Oracle Analytics Cloud. If you have some problem, okay, send your email on the Slack channel, okay, and we will try to provision and to whitelist your account. Okay, what is the objectives of these sessions, of these Hands-On Labs? Okay, Oracle is working with Red Bull, okay, like a partner of Red Bull Enterprise for the Formula One, and we want to use the data set from the Formula One to apply some analytics and some machine learning algorithm. Okay, with this data, okay, you can understand better how you can implement the different machine learning algorithm in the different services of Oracle. You can make better decisions, okay, on this data set. Okay, we will create some insight. With Formula One, okay, we can provide some great learning context, okay, and you can use this data set to increase your insight and to develop more machine learning algorithm in the future. Okay, today we will practice in Autonomous and using the data set from the Formula One. Okay, we have prepared for you, and in the tutorial, okay, you can download all this information to your PC and you can upload this information directly to the Autonomous and to the Oracle Analytics Cloud. The challenge is to identify really for the fans, for the Formula One fans, to identify the great Grand Prix. And what is the reason this Grand Prix has been really good, have a good score. And we will try to identify, okay, all the reasons, all the factor, all the feature on this data set to analyze really the good Grand Prix and the bad Grand Prix. Okay. it is objective of this hands-on labs. Okay, I will show you some video from Red Bull. Okay, I hope you try to provision your account. Okay.
Competing one of the biggest sports in the world. There's always adversity. You're going to lose more races than you're going to win. But it's those days that you learn the most. Data is our lifeblood in Formula One. Everything we do is driven by the data that these cars create. We're not allowed to practice like in other sports. So we have a virtual world, which we rely very heavy on, but also on the data that these cars generate and how we use that data. We need to be more personalized, and look, we want to be able to give the fans an insight that they can't get anywhere else. We're in a fortunate position where we can afford to be quite choosy of the partners that we want to work with. It's not just about having a sticker on the car. It's about the technology that it puts into the car as well. And so therefore, a partnership like the one we have with Oracle, the technology that opens up to us is so exciting. At the end of the day, it's about working with your team to try and take on some of the best teams, some of the biggest brands in the world. And when you achieve that, that's the biggest sense of satisfaction.
Okay, after this video, okay, explaining why the data is really important for Red Bull. Okay, it is the agenda for this hands-on labs. Okay, in the first step, okay, we will prepare the environment. Okay, for the cloud, to deploy the different services. Okay, if you cannot finish, okay, don't worry, you can do later. Okay, the labs, okay, will available for you for 1 month. Okay, and you can terminate this hands-on labs later. Okay, and you have this cloud for trial account, okay, for 1 month to use these services, okay, with the credit, okay. The first step is to provision your free trial account. Okay, you need to click on this trial. Okay, I hope you have provisioned your account. Okay, before this event, you in the email you have received today. You can create your account, okay, directly on this Oracle Cloud, okay. And now, in the first step, okay, I will change my screen, okay, to show you the provisioning. You have the tutorial here, okay, in the lab guide 0127, okay. To this guide, okay, you have this information, okay. You have all the different steps of this labs, okay. The first step, okay, when you create your account, okay, you have provisioned your account. Okay, now I will go out of my to show you. Okay, I will change my tenant. Okay, you need to connect to your tenant, and you need to have this. If you put cloud.oracle.com, okay, you put your name of your tenant, okay, you have created in the process, okay, for the creations, okay, and you can access to this information, okay. So you have all the tutorial here, okay, all the different steps, create your free trial account, okay, on this console lab. You can follow all the steps, okay, in the tutorial. When you connect to your account, okay, you connect to your tenant, to your tenant, okay, you should have this window, okay. You can have this window to connect to the identity cloud service, okay, for your federated user. When you receive a mail with a fully provisioned, okay, when you have an email with fully provisioned on your email account, you can access to and you can connect to your cloud tenant, okay? And you can access to your information. So the first step, okay, in this lab, okay, is to provision directly this analytics cloud and this autonomous. Okay, in the first step, okay, my colleague Jero and Klosterman, okay, will present the machine learning challenge, okay, for this console lab today, okay.
To work on the challenge, you require a basic understanding of machine learning. So what is that exactly? It's basically a collection of different algorithms that let you find patterns, find anomalies, and make predictions on typically large amounts of data. So data is the key to machine learning. I'm going to focus on a particular part of machine learning called supervised learning. And in supervised learning, the idea is that you train a model from a lot of example data. And then you use that model to predict what's going to happen next. To illustrate this, I always like to use the example of house price prediction. And we'll come back to the racing context in just a few minutes. So let's say we want to predict the price a house will sell for, purely based on its size. And we have all this example data of houses that were sold in the past. We know their size and the price they were sold for. So we can plot this in a chart. On the vertical axis, you see the house price, and on the horizontal axis, you see the size of the house. Simply put, training a model is about fitting a line that best presents the pattern in the data. In fact, that's exactly what the linear regression algorithm does. It tries to find a straight line that best fits the data. This line is basically our model. So when we have found the function or the definition for this line, we can say that we've trained the model. Then you can go to the next step, which is making a prediction. Let's say we have a house of 200 square meters, and we would like to know what price it is likely to sell for. Our model will now tell us that the house is likely to sell for about 400,000. So you see how a model generalizes from example data, often historical data, and is then able to predict the values for new data. Now, of course, this is an oversimplified example. In this case, we only had one input feature, the house size. But in practice, you'll train models that look at multiple variables like the number of floors, whether the house is a garage, the neighborhood of the house. So then you can imagine that the resulting function becomes a lot more complex, and too complex actually for a human being to find. But the idea is that, generally speaking, the more relevant data you can give to the algorithm, the more information about each house, the more accurate the prediction will be. So now let's come back to our racing challenge. Our goal is now to identify the factors that will make a great race. We have race data from 1915 until now. For example, for each race, we know its location, the date, the number of overtakes, the weather, etc. We also have a fan score per race between 2008 and 2020. The website racefans.net collected this average race score from thousands of fans, and we'll use this number as our ground truth of exactly how good a race is. So our first job will be to think of candidate factors that we think or that we suspect may be related to the score of a race. For example, the number of overtakes, the weather situation, or the actual circuit where the race takes place. Now, for us as human beings, we may have some gut feeling of what factors may be important to predict that race score, but it's really difficult for us to quantify exactly how those factors influence the score. Certainly when there's many factors at play. So that's why instead, we will use the power of machine learning to try to learn what those relationships are. So the idea is that if we can show that we can accurately predict the score with a machine learning model, then we also have solid grounds to say that the factors that we train this model on are indeed the right ones. We will go through two phases. In the training phase, we will take all the data that we have until the end of 2019 and train a model on it to find out how exactly score is influenced by all those factors that we've identified. And once trained, you can see that model as a thing that understands the relationship between all of those factors and the score. So then once we have that model, we can turn things around. Then we will take the year 2020 and we take all the data that we have on the races, all the same factors, and then we use the model to predict the scores for that year. The interesting thing is for 2020, we're making predictions of the race scores, but we also have the actual ground truth fan scores for that year. And because we have both values, we can compare them. Here you see the end result that you'll try to create yourself. Our ground truth, the actual scores of the fans, they are in blue, and the predicted scores by the model are in green. If you manage to get through all of the steps of the labs, then you should see a very similar result. And you'll see that the actuals and the predictions are pretty close, which is an indication that our model is accurate. And once you have that, you could actually use this model and predict the scores for the races of 2021, for example. We don't have the actual fan scores for 2021, but that doesn't matter because now we can trust the model and we can trust that the predictions will be pretty accurate. And most importantly, we now will know that the factors that we've chosen to train the model are indeed the right ones that we should be working on to try to make races even more interesting. So guys, this is the challenge. I hope you're able to produce a similar result as what you see here on the screen.
Okay, after this presentation from Jeroen, okay, we will try to reproduce, okay, and to have the same results, okay. Now, my colleague Nada Magui will present the different services, okay, we will use today in this hands-on labs, okay, Autonomous Data Warehouse and Oracle Analytics Cloud, okay. Don't worry, okay, I will give you more explanation, okay, during these sessions, okay, in live, to explain more functionality on this service, okay.
Hi, everyone. So before we let the race begin, so to speak, I just want to give you a quick overview on the services that we're going to be using for the purpose of today's lab, right? And basically what each of them brings to the table and what each is comprised of, right? So with that being said, this is just to give you a global view on how they come together. Those two main services that we're going to be using are the Autonomous Data Warehouse, which is going to be covering the machine learning side of things, right? And essentially data is at the heart of machine learning. And we have almost 70 years worth of data in this practice. So it definitely makes sense to have that data warehouse to store the data in. And then the second service, which is the Oracle Analytics, this is going to be our visualization platform, right? Before jumping into machine learning, there's a lot of, let's say, qualifying, to use the term correctly, that has to be done in the back end for the data to be ready to be used for machine learning purpose. So visualizations help kind of move things along in that regard. So we're just going to dig a bit deeper into each of those services, and starting off with the Autonomous Data Warehouse. So what is the Autonomous Data Warehouse? It is essentially Oracle's latest database version running on infrastructure that is primed for analytical processing, right? That is its main purpose. One of the main features is that it has automated data management. So it intelligently, automatically configures, tunes, updates your data warehouse without any manual intervention. And with that, you eliminate the possibility of human error, right? So you have more time to focus on what you need to achieve rather than the management side of things. You are guaranteed consistent high performance because of the automatic table indexing and tuning, and also the ability to auto scale. So with auto scaling, you actually get an increase in compute as well as IO, up to 3 times the initial amount, just to satisfy the needs of the workload. And then it goes back down accordingly when not in use. With that, you suffer no downtime at all. And that's a huge advantage, right? Typically in that scenario, you definitely would have to suffer downtime. You also have the comprehensive data privacy and protection because data is always encrypted, whether in transit or at rest. And the patches are automatically updated for you as well, so you're guaranteed security. And last but not least is that it is a complete solution that has built-in analytics, right? There are built-in machine learning algorithms that are provided for you, along with graph analytics and spatial support. So we are truly empowered to make use of the data warehouse, right? And typically with these large amounts of data, there is an issue if you have to move the data to an analytical platform. But in this case, we're moving the analytics, the machine learning to the data right on top of the data. And then we can start to visualize those insights at a later point in time, right? So you're guaranteed reliability and security at in one shot, in one single place. So next we move on to the Oracle Analytics. And I like to think of this as a one-stop shop, right? Sort of like a mall, where in a scenario you need to run some errands, you need to do some grocery shopping, do some transactions at the bank, get some stuff from the pharmacy, drop your kids off at nursery while doing all these things. So in a typical scenario, you'd have to go to all of these different places. You spend time, effort, money. But with the option of a mall, you get to do all of this from one single place. And this is the same idea when it comes to Oracle Analytics, right? You can start to connect your data from a variety of sources, whether they may be databases, Excel sheets, CSV files. You can then start to prepare or modify that data. Maybe you want to do some semantic modeling as well. You are truly able to do that. And then you can start to explore that data through the different visualizations that OAC has to offer, as well as some machine learning capabilities as well from OAC side with one-click advanced analytics, right? Once you're satisfied with your content, with your dashboard, then you go ahead and share that content, either by exporting it in, let's say, PDF or PowerPoint format, or even better yet, you can actually embed that content into web applications or mobile applications. And regardless of the type of user that you are, so technical, not too technical, whatever it may be on the grand spectrum, you are truly empowered to make full use of the features that OAC has to offer, right? And whenever we specifically mention the term machine learning, one starts to think, well, that needs someone technical, right? You need some programming expertise like Python or SQL. But what Oracle Analytics really has to offer is that you don't need any of that because it's just that simple, right? And from there, you can preach your heart's desire, really, and the sky is your limit. So I hope that's given you a really good idea of what the services have to offer, what they're about, and happy racing.
Okay, after these explanations, okay, we can begin to work with the environment. I hope, okay, you have provisioned your Autonomous and your Oracle Analytics Cloud, okay, from the lab one. Okay, now we can load the data, okay. I will stop my presentation here and we can work now in live. Desktop one. Okay, now we can work, okay, on the cloud environment. Okay, I can connect, okay, with my user directly. Okay, you have executed this step, okay, to provisions, okay, your Oracle Analytics Cloud using this step, okay, with your user, and you can create an analytics cloud. Okay, I will connect to my environment here, and I will show you how you can provision directly the service. Okay. Now, when you receive the email fully provisioned, okay, you can connect to this platform using the identity cloud service. Okay, your identity provider. Okay, to have a single sign-on between the different services, and here, okay, you can provision directly the analytics cloud. Click on Analytics Cloud. Okay, you can use the hamburger. Okay, the hamburger, analytics and AI services. Okay, and you can select the Analytics Cloud. Okay, you can create an instance. Okay, if you follow the tutorial. Okay, I suppose you have created this instance. Okay, you can create on your compartment. Okay, the compartment. Okay, is the same behavior if you compare with Windows the folder. Okay, you can organize all your different platforms on the cloud service, okay? And we can create different compartments. Well, in this case, okay, you have creating an account, a free trial account, okay? And in this free trial account, you can deploy your platform directly on the root compartment by default. Okay, you put here the name, Red Bull Analytics, okay? You select the enterprise analytics, okay? In the tutorial with a free account, okay, you can use one OCPU, non-production OCPUs, enterprise analytics. Okay, the license included, and you can click on the create, okay, and you deploy these actions. Okay, I have here my Red Bull Analytics instance. Okay, and the first step for this provisioning is around between 10 minutes and 20 minutes. Okay, so for this provisioning, And the second step, the second service, okay, we want to use is we want to load all the data, okay, on this laboratory, on these labs, and we click on here on Oracle database. You have different services, and today we will use the Oracle Autonomous Database, okay? And in this Autonomous Database, okay, I can create an Autonomous Database here, okay? On my same compartment, okay, you put the name here, for example, Red Bull, okay? The database name Red Bull, okay? In the tutorial, if you follow the tutorial here, okay, you have this information on the second lab, provisioning the autonomous, okay, you click on the provision autonomous here, okay, and you have all the step, okay, I will do with you, okay, all this step. You have the data warehouse, okay, you choose the data warehouse, you put this information, okay, here, Red Bull, data warehouse, shared infrastructure, okay, we have two types of services, okay, dedicated infrastructure or shared infrastructure. In shared infrastructure, okay, we can deploy one pluggable database for you, and you can access it, you can pay only for your usage, okay, with this type of architecture. You can select here always free, okay, or in this case, okay, don't select the always free, you put the 29, the version 29, okay, for this free trial account, okay, I can choose one OCPU and 1 terabyte, okay, and you can select the OCPU auto scaling by default, okay, for this user. And here you, by default, okay, when you deploy this database, this autonomous database, we create a user, an admin user, okay, and this admin user, if you follow the tutorial here, okay, if you change you can change the password, but you need to remember your password, okay, or you can select this password, okay, Oracle _12345, okay, this password, okay, and on this creation here, okay, you can select and you can copy this password, okay, here, okay. You select the security access from everywhere, okay, and in this case, you publish your autonomous, okay, to internet access, okay, and you can access with different applications, okay. Bring license included, okay, on these versions. You select license included, okay, and you can put your email, okay. If you put your email, you receive some notifications from the autonomous service, okay. Automatically, you receive an email when this service has been provisioned, and you receive an email for the different notification inside the autonomous database, okay. And you click on create autonomous database. And here you can provision this service, okay. You have this service provisioned here, okay. It is the lab 1 and the lab 2, okay. I hope you have executed these 2 steps, okay, at the same time, okay. Autonomous, okay, it's around 1 or 2 minutes for the provisioning, and the Oracle Analytics source is between 10 and 20 minutes, okay, to have an access on this instance, okay. You can execute in parallel these 2 tasks, okay, without any problem. Now we can go to the lab 3, okay. In the lab 3, we want to load all this information, okay. We want to load all the data set to reproduce, okay, the same result, okay, showed by Jeroen, okay, in the previous video. Okay, in this case, okay, you are here, you have your autonomous. When you are in the state available in green color, okay, you can access to your autonomous, okay. You can click on this service. And on this service, okay, you have the different informations, okay, 1 CPU count, 1 terabyte, okay, you have the license, you have some information on the auto scaling, on the backup, on this information, okay. And if you want to access and to load your information, okay, you click on the database actions, okay. When you click on the database actions, we open different tools, okay, available with the autonomous database, okay. You have here different tools, okay. You can create your select, okay, your different select. You can create a script with SQL. You can publish different tables or different views with the REST API. You have a data modeler. You have a JSON you can create a database JSON document, okay, in this autonomous. You have an Apex application to develop directly RAD applications, okay. You can generate some chart, okay. You have the, you can manage multiple users to access to your database. And you have different tools here, okay. Data pump, data catalog, okay, on this data actions, okay. If we follow here the tutorial, okay, the first step is to create a user, okay, to create a user. So for this step here, okay, you have a script, Red Bull create user, okay, you can download this script, okay, you download this script, okay, and you can here, I open. I download, okay, I can edit this script. Okay, and you can copy all this code, okay, to here, okay, I'm connecting like admin, okay. The first step, okay, when you click here on the database actions, okay, you connect with the admin user, okay. Okay, the first step, it's possible, it's possible, okay, the autonomous database ask for the password, okay, Oracle _12345 to access to this user. If you want to create this script, you click on the SQL, okay, and you are connected to the admin user, okay, on your schema, on your database schema, and you can create here, okay. You click and you copy this script. This script, okay, is to create a F1 user on your database, another user, okay. We don't work with the admin user. We will create a specific user, F1 user, with this same password, Oracle 12345. Okay, we assign the specific role, data warehouse role, okay, to F1 user. We put the quota unlimited on this for this user. We create grant some sessions, some tables. You can create tables, okay, for this user. To execute this script, okay, you don't click on this button, on this green button, okay. You click on the second button here, okay, run a script, okay, directly. You run all this script on your schema, okay. You click on this button and you execute all this script. This script create and publish all the entry point, okay, like a REST API, okay, directly with this script at the beginning, and we create the different table, races, safety car, pit stop, results, okay, driver standings, directly on this database, okay. When you have executed this script, the next step is to check, okay, the result, okay. You sign up to this user and you connect with the F1 user, okay. When you connect with the F1 user, okay, you put F1 here, you put your password, okay, the same password, Oracle _12345, okay, and you connect directly to the database actions, okay, here, and you can access to the SQL. You can verify here, okay. You have your tables, okay, creating on the schema, okay, the lap time, the pit stop, okay, the races. You have all these tables. I have more tables because I have executed previously all the console labs, okay. And you have all this information here, okay, on this schema. You can go now to your data load, okay. On the data load, okay, it's a tool, okay, for the database actions. You can execute with this graphical interface, okay. You can import directly all the data set, okay. In the tutorial here, okay, you have executed this information. You can go out, okay, and you can download all this information. Races, okay, you download this data set, lap time, safety car, okay, pit stop, race results, okay, driver ranking data, okay. You have all your information on your PC, okay. And now, okay, you connect with the F1 user, okay, on the tutorial. And we can use the data loader, okay, I will use the load data, the local file, okay? And here, well, you can load your information from other database directly from the cloud storage, okay? From the Oracle cloud storage, from the Azure blob storage, from the Google storage, or the Amazon storage, okay, the S3. Okay, you can import your data from this, connect directly to this storage, okay? In this case, okay, we'll use my local file, okay? You click on next, and you can select your file, okay? Here, you select your files, okay, from your download. Here, you can select all these files. I have downloaded now, okay? And I have created the tables, okay? These tools, okay, you can create automatically a tables, okay? You on your schema, okay? Because we can detect, okay, the structure of your CSV. In this case, okay, you have created the table with a script, with a SQL script previously, okay? You can go here, okay? You need to change, okay? I don't want to create another table. I want to reload my data, okay? For you, you need to select insert into tables, okay? If you select insert into tables, okay, you put here the safety car, okay, the table safety car. In my case, okay, I will replace my data, okay. This safety car, I will put the safety car here, okay. And you need, okay, to change, you need to put your information, okay, your CSV, and you need to change for the 6 files, okay. You select here, you put insert in the table, okay. We can create a table with these tools, but we have executed the script previously. So now we need only to insert in the table, okay. For me, in my instance, I will create a replace data. I will replace all my data, okay, to execute the same console labs, okay, with you. This is, okay, the 6 files, okay, and check perfectly, okay, at the end, okay, you have here on the target, okay, the good name of the tables, okay, the races, the safety car, okay. Insert for you, replace for me, okay. It is a pit stop. I will select the pit stop, close, okay. I will select for the results, okay, replace my data set. For the results. For you, insert. Okay, you select insert on these tables, okay. You follow the tutorial, okay. Replace data. For me, it is a lab time. Okay, check, okay, previously to push this button, okay, these executions, okay. Check you have the good name, the target, okay, the pit stop, the results, lapse time, driver standings, and races, okay. If you are okay, okay, you can execute directly a job, okay, to load all these data sets. Okay, we are executing all these tasks, okay, on the autonomous database. You are importing all your information, okay, and the big files with all the lap times for the different races, okay. So we are executing the load data, okay, this lab 3 and these sequences, okay. We are executing this information, okay. You have this information here, okay, you need to change, you put insert into table for you, okay, because it is your first executions, okay. And at the end, okay, we have loaded, sorry, here, we have loaded all this information with a check, okay. So we can click on done, we have done this, okay. And now the next step, okay. We have executed all this information here, okay. We have loading We have loaded all the information, and now we can execute some data explorations. Okay, on the data explorations, the first step. Okay, the data explorations. Okay, we will use a specific service, Oracle Analytics Cloud, to connect to the autonomous database. It is my first step. Okay, so in the tutorial here, okay, we need to go, okay, to the autonomous. Here I am in my autonomous. Okay, and you need to select your autonomous, and you need to select the DB connections. Okay, here you have this button, DB connections. Okay, previously we click on the database actions. Okay, and now you need to click on the database connections. On these database connections, okay, to connect with some security mechanism to the autonomous database, okay, you need to download the wallet. Okay, here you have different options. Okay, you can download your wallet to your PC. Okay, you put a password. Okay, put the same password, Oracle _ 12345. Okay, Oracle _ 12345. Okay, and you download a zip. Okay, on your directory. Okay, if you check, okay, this zip, okay, you have some information on this zip. Okay, directly you can extract. It's not necessary to extract, but I will extract to show you. Okay, all this information. You have in this zip, okay, you have some information. You have the wallet, okay, you have the SQLnet.ora, you have the OGDBC properties, the trust store, okay, the TNS name, the C wallet single sign-on, okay. You have all this information to connect from external applications, okay, to your. I will check if we have some questions. Okay, no questions here. Okay, you have this zip. Okay, it is the first step in the tutorial. You need to download this DB connection for you. Okay, you download this wallet. You put with a password. Okay, you have all this information, and now you can connect to the Oracle Analytics Cloud. Okay, I can go here on the hamburger from the interface. Okay, the graphical interface of the cloud. Now I can select the Analytics Cloud. And I can select my service, okay? My analytics service, okay? This service, you click on this analytics service, okay? And you have all your information from these tools, okay? You have an enterprise analytics license, okay? You are using, okay, you have this URL here, okay? And you can click on the button on the top, okay? Analytics homepage, okay? If you click on this, okay, we are opening directly the Oracle Analytics Cloud, okay? The Oracle Analytics Cloud, it's a graphical tool, okay, to compete against Tableau, Power BI, or all these tools. Okay, you can create different workbook, different workflow in this service. Okay, you have on the hamburger on the left side. Okay, you can create some data set. Okay, you can import some data set. Okay, you can create some machine learning algorithm. You can create some jobs. Okay, you have all this information. Okay. In this case, okay, you want to connect to the autonomous, okay? To connect to the autonomous, okay, we will create the connections, okay? You need to go, sorry, I will move this button. Okay, you need to go here on this button on the create, okay? And you can create a connection here, okay? You have the functionality. You can create a workbook to create some insight, okay, some data sets, some data flow, okay, sequences, okay, you can create some replication of data, and you can create a connection. The first step for you is to connect, okay, directly to this autonomous service. You can see here, okay, we have lots of connectors, okay, you don't pay for these connectors, okay, on these connectors, you can access to different databases, to different services on the cloud, okay, on different clouds. And in this case, we need to select the autonomous data warehouse, okay? You need to put here the Red Bull connections, okay? And here you need to select your zip file. You need to select here. I will move this. Okay, you need to select the zip file, okay? When you select the zip file, Okay, you can see here, okay, we are reading the C wallet.single SSO, okay? And you put here your user. Your user is F1, okay? Red Bull, I will create a new connection, Red Bull 2, okay? And my password is Oracle _ 1 2 3 4 5, okay? And you can select, okay, we have different pools of connections to the autonomous, okay? The medium connections, the low connection, or the high connections, okay? In this case, we will use the high connections, okay? And you save new connections, okay? So you have created these connections. Now you are, okay, if it is okay, you have the green message at the end, okay? You are connected this Oracle Analytics service to the Oracle Analytics Cloud, okay? I can open here my Oracle Analytics Cloud to another tab. Okay, here. Oh. I'm connecting from this service to the autonomous, okay? Directly here on my autonomous, okay? The next step on this console labs, okay? We have done all this step. I can create some insight, okay? Okay, I can create some data set. Okay, you can create some data set on your connections, okay? In this case, okay, for you, here in the analytics, in the analytics cloud, okay, you can create data set. Okay, you can select your connections to your autonomous, okay, and you have the access to your autonomous directly. You have all your information, and you can see here you have your admin, you have your F1 user here, okay, and in the F1 user you have all your tables, okay. In this case, okay, I will use the races tables, okay. You check your races tables here. Double click. Yes, it's okay. Okay. We have all these informations, okay, of these tables, okay. So race ID, the year of these informations, okay. You have all the distributions, okay, directly on these representations, okay. And now, okay, you can see the year, okay, you can see all these informations. We have the information from the last 20 years, okay, on this data set. You have the F1 date, okay, you have all these informations directly on these representations, okay. And we have the score of the fans, okay. I think I can move it. Okay. And we can select, okay, on the bottom, the races tabs here, okay, on the bottom here, okay, you can select here. You have all your information on this, okay, on these representations, okay, and you can select here on the top, this bottom, okay. This is a specific column configuration here, okay. You click on the column configuration on the bottom, on the top of this interface, okay, and you have all your different attributes, okay, on these tables here, okay, measure, okay, attributes detected automatically by these tools, okay, when you connect to these tables. Now we will change, for example, here, okay, race ID, it's a specific identifier, okay, from the Formula One website, okay. The year we pull attributes, okay, you can change all these informations, attributes of the run, okay. No, I don't change here, no, I don't change this, okay. We put measure, okay, follow measure, and measure here, okay. The next is the score, okay. The score is the score from the fan here, okay. We put measure, and we change, okay? It's not assume, I want to use the average method, okay, on this score. And you have the different score here, okay, on the sample value, okay, on this interface. And you can save these informations, okay, here. You save, okay, and you put your data set, okay. My name, I will put races, okay, to races, okay. And you have connected to the races tables, okay, and you can create a specific function here, okay. You can modify some data directly on this data set, okay. You have created on the tools. The next step is we will do the same with the lap time, okay. You create a data set here, okay. You go to your Red Bull connections, lap time tables, okay. Here, lap time tables. Double click, okay. And we will change in this, okay, same step, okay. You have all your information on the positions, okay, from the different lap for the different races, okay. And you have the position of the drivers, okay. You have the positions of the in milliseconds, okay. You have the time in milliseconds, okay. You have the race name for the different races, okay. If you have a pit stop or not pit stop in this lap, okay. You have all these informations, okay, on these tables. We will click on the bottom on the tab lap time, okay. We have these representations. We use the column representations, okay, here, and we can change, okay. It is not a measure, it is an attribute because it is a specific ID from the Formula One website, the driver ID and the lap, okay. We'll put these three fields, okay, like an attribute, okay, in my data set, okay. And you can save your lap time. Lap times, okay, for example, okay. And you save, you have this message where the dataset was successfully saved, okay, and you have all this information here, okay. Now the idea is to the first step, okay, in my insight, I would like to know what is the best and the worst race, okay. And for this, okay, you are in the home page here on the analytics, you click on the data, okay, you have this information lap, your table, okay, your data set lap time and races, okay, and you can select the races, and you can open here a workbook, okay, you can create a workbook, okay. This workbook, okay, it's a visualizations, okay. You can create some insight using this graphical interface directly, okay. You can click on the score, for example, here, and I'm using this score and the name here, okay. If you are with Mac, okay, in the tutorial here, I will show you in the tutorial. We are in the here finding the best and the worst, okay, for the fans, the best and the worst score, okay. Here in the tutorial, we put control plus click, okay, to select two fields at the same time. If you are with Mac, okay, it's my case, okay, you are using the command, okay, you need to use the command. And you click on these two fields with the command and you pick the visualizations, okay. And the first visualization, we have different visualizations on this analytics cloud. You can, we have a specific library on the cloud. You can download specific widget. You can import specific widget in JavaScript on this tool, okay, if you want to extend some visualizations, okay. And in this case, okay, we will drag, okay, directly these informations as the tables, okay. You can use the tables here, okay. And you can see we have lots of scores, okay, in the data set, okay. We have lots of information without any value, okay. Now the first step is to clean, okay, this data set. I will take the score, you can drag the score, okay, on the top here on the filter toolbar, okay? You click here and you put, I want only to check the value if I have a score from the racefan.net website, okay? And the score is between 0 and 10, okay? If you put this filter, okay, now you have only all the races, okay, with a score, okay, on the data set. And you can select, if you click on this arrow, you have the best race, okay, the best score. It is 2012, okay, Brazilian Grand Prix. And if you click on the other arrow, you have the worst race for the fans, okay? It is Abu Dhabi, okay? 2020 Abu Dhabi Grand Prix, okay? So we have detected the worst and the best race, okay, for the fans. Okay, it is this results, okay? Here we have, okay, we have the Brazilian and we have the Abu Dhabi 2020, okay? And we can save this workbook now. Okay, you can save this workbook. Where is this? Okay, you can save your workbook. Okay. The next step. Okay, we can go back to the home page. Okay, here you can go back to the home page. And the next step is to use, okay, to work on the overtake and the DNF, okay? When you are a fan of Formula One, okay, probably you like, okay, it's, okay, we think, okay, probably you like if we have lots of overtakes, okay? You don't like if the race is a train of cars, okay? You prefer if you have some specific movement during the race, okay? Okay, we want to check the overtakes, and the DNF, it's a do not finished, okay? And if you have lots of driver, okay, does not finish the race, okay, probably it could be a good race with some specific interaction during the race, okay? And probably it's 2 parameters, okay, it should be fine to check these 2 parameters on the data set, okay? Donc we will check with using the lap times, okay, tables. You take the lap times tables, okay, you create your workbook on this lap time table, okay? And now, okay, you can select, we have detected which race is the best and which race is the worst, okay? So we can take the race name here, okay? We can filter with the race name, okay? I can put here 2020. It was 2020 Abu Dhabi, no? The worst race. And I can select the 2012 Brazilian race, no? 2012 Brazilian Grand Prix, okay? I'm selecting only here, okay, these 2 races, okay, in this filter. Okay, and the next step, I will check the lap. I will take the different attribute lap, positions, and driver reference. Driver reference with a command for my PC with control with Windows, okay? And you can pick a visualization, pick visualization with the right button, okay? And you can select this visualization, okay? You have all the different positions, okay, for the different drivers, okay, here during this race, okay? You can see, okay, for the 2 races, okay? Okay, if you want to divide this information, okay, you take the race name here, okay, in trellis row, and you can divide this information, and you can compare the 2 races, okay, directly in my insight. In this insight, okay, you can select, okay, Abu Dhabi, it was the worst race for the fans, okay, and you can see here we don't have lots of changes, okay, on the positions, okay, during this race, okay, and you can see the Brazilians, okay, you have lots of changes, okay, position changes for lots of drivers. Okay, it could be a good insight. Okay, good KPI for my model. No, I need to. Okay, in this system, probably this parameters, these positions. Okay, it could be really interesting. Okay. Donc the total number, the conclusion of this. Okay, it's on this insight here. When you execute this information, okay, the total number of positions, okay, changes may be a factor to predict a race score. Okay, it's probably okay. I prefer to see a good race, okay, with lots of position changes. Okay, it is the first conclusion of this. Okay, the next, okay, we can select, for example, here. I can select the positions. I can take the positions here, and I can add another filter. Okay, I have some capture here. Okay, I can drag the positions like another filter, and I can put the position 1 to 5. Okay, 1 to 5 positions for the race. And you can see, okay, for the bad, okay, the worst race, okay, we don't have lots of changes. Okay, only one change is here. Okay, and for the other Brazilian Grand Prix, okay, we have lots of changes in the first 5 positions, okay, of this race. Okay, donc the number of changes in the top positions, okay, it is the conclusion of this insight. Okay, the conclusion is here. Okay, the number of changes in top positions may be a factor to predict a race score. Okay, I can delete this filter. We can come back to these representations. Okay, and now if you select here, for example, Hamilton, okay, you can see Hamilton does not finish this race in Brazilian here. Okay, you can see Hamilton does not finish. Okay, you have the same conclusion with Grosjean, with Pastor Maldonado. Okay, they did not finish the race. Okay, probably the does not finish. Okay, does not finish the race could be a factor for my predictions. Okay, my model. Okay, and you can see lots of drivers. Okay, they did not finish. Okay, you have Hamilton, you have Di Resta here, Resta. Okay, is not finished. You have another driver, Grosjean, Maldonado. Maldonado, they did not finish the race. Okay, in the first. Okay, in this first positions. Okay, in the first lap. Okay, well, probably the conclusions. Okay, the do not finish. It could be a good parameter. Okay. Now I can add on this workbook. I can add the information. Okay, I can join the information with the race. No, you can click on this button, on the plus button here to add a data set. Okay, you can add your data set, your race. Okay, this race information. Okay, and now we have 2 data sets on this workbook. Okay, you have the lap time and the race. Okay, and you can select all these fields. For example, all these fields. You can select and you can create a peak visualization with the shift button. Okay, with the shift button, you can select all peak visualizations. Okay, you can select the tables visualizations. You can move directly this widget on the bottom. Okay, directly, and you have all this information from this race. Okay, from these 2 races. Okay, Brazilian and Abu Dhabi. Okay, you have this information here. Okay, and you can check some parameter, really interesting parameter. Does not finish. Okay, the number of driver does not finish the race. Okay, the driver does not finish due to accident. Okay, you have this information here. Okay, the number of overtaken here. Okay, you can see the difference between the best race and the worst race. Okay, all these parameters probably, if you check in your data set, okay, could be really interesting to integrate on my model, on my machine learning model. Here you can see this, it's a with a weight, okay, it's a with a weight, okay, with a weight, yes, and in the rest of Abu Dhabi, it's no weight, okay. Well, it could be another good parameter to integrate in my model. Okay, now you can discover really all the different, okay, you can save this workbook, okay, like race analysis 2, okay. Okay. The conclusion of this inside visualizations, okay, is the overtaken positions. Okay, it's a good parameter for my model probably. Okay, the number of does not finish, the number of driver does not finish the race could be another good parameter, good feature for my model. Okay, the DNF due to accident, okay, another good parameter for my machine learning model. Okay, and the weight, okay. All this information probably I need to integrate, okay, on my model, okay. I need to use all these features on my machine learning model, okay. We are executing this step, okay. What is the time? 7, okay. For the next part, okay, I don't execute this part because you can do it on, okay, we can create a scatter plotter, okay, directly, okay. For example, I will do it, okay. I will select here, okay, my races, okay, create a workbook, okay. I will execute some correlations, okay. You can execute some correlations on your different feature. Okay, in this case, you select the races, okay. We take the score, the name year, the score. I want to predict the score, the name year, and the overtaken positions, okay. You can take all these informations, pick a visualizations, okay. You can use a scatter plot. The scatter plot, okay. You have this representation here, okay. On a scatter plot, you have all the distributions of your different positions, okay, comparing the score with the overtaken position total and then the name year of the race, okay. We can categorize by the name, okay. I need to change this to have a better representation. Okay, in these distributions, okay, you can see the good score here, okay, the high score, okay, depending on the number of overtaken positions, okay. You can see some information here, okay, and you can apply some analytics directly on these visualizations, in this widget. Here, you can add statistic, okay, the trend line directly, okay, and you can see your score, okay, this trend line, okay, your score increase if you have more overtaken position, more changes, okay, position changes on the race, okay, on this distribution here, okay. We can do the same, okay, you can duplicate here these representations, okay, you select, okay, this menu bottom, edit, duplicate visualizations, okay. You can move these duplicate visualizations on the bottom side, okay, and we can do the same with did not finish, no? Like we can change here, I can take and I can select, okay, these visualizations, and I can change my bottom does not finish the counter. I can take this here, okay, and you have these distributions, okay. So we have a trend line, okay. If you have lots of driver don't finish the race, okay, probably the score increase, okay. Like it is another insight to demonstrate this part, okay. And we can do the same, okay, we can duplicate. Now, okay, the last part of this insight is to duplicate these visualizations, okay. drag and drop this visualization at the bottom, and you can do the same with the does not finish due to accident here. Okay, and you have the same result. Okay, it seems lower, okay, lower importance on my model, because this trend line is really poor increased. Okay, but it could be interesting to integrate in my machine learning model. Okay, you can execute some questions. I see some questions. Okay. Okay. Yeah. Okay. In this case, okay, we have demonstrated here. Okay, you can save these representations. Okay, like another correlations. Okay, correlations to, for example. Oh, okay. And this, okay, if we continue in this correlations diagram, okay, you can check, okay, more insight. Okay, here, for example, you can execute these person representations. Okay, to check your importance on your different features on your model. Okay, you can see the, okay, on these representations. Okay, for example, the overtaken position total, it's really more important on my machine learning model. Okay, you have all this, it is the highest person correlations. Okay, and well, you can execute this step. Okay, I would like to execute more part of this hands-on labs. Okay, and you can save all this information. Okay, you can execute a box plotter for the wizard, for example, here. Okay, you can do the same. I will do it now if you want. Okay, we can do here on my, okay, I can use the box plotter. Okay, I can take the score, the wizard weight, to check the importance of the wizard weight, for example. Okay, and the name here. And you can select the right button, the visualizations. Okay, the box plotter here. Okay, box plot. And I can change the bottom here. Okay, and you need to change here. Okay, the wizard weight. Okay, the name here, like a detail box. Okay, and you can see here. Okay, if the race is in weight, okay, as you have weight wizard, probably your score is really higher. Okay, here. Okay, on the box plotter. So probably it's a good parameter, a good feature for my machine learning model. Okay, you can save your step. Okay, so the conclusion of this part of this hands-on labs. Okay, here the conclusion is data 6. Okay, you can see the number of position of changes are really important. The number of does not finish is really important on my model, and the wizard is another feature really interesting on my machine learning model. Okay, it is my discovery. Okay, my exploratory discovery on my data set. Okay, now we can go to the labs files. Okay, we can execute. Okay, in the lab files, for example, more features. Okay, in this lab file. Okay, we can execute, for example, in the first type. Okay, here. Okay, we can create here the comeback score. Okay, on this race. Okay, you can select specific drivers. Okay, you can see this. You can inspect in your chart. Okay, we are executing the different position here. Okay, directly on this chart. We can analyze the pit stop. Okay, on the next step. Okay, we can analyze this pit stop. Okay, for the different race. Okay, here you can execute these representations. Okay, on the pit stop. we can create a specific, okay, probably it's really interesting to understand the positions, okay, the position changes. We have introduced a specific concept, okay, the ghost car. Okay, the ghost car is a concept, okay, to like the virtual car. Okay, when you have a virtual car on the different race, probably you have more interest for the different fans. Okay, it was the case for the last race, the last year. Okay, in Abu Dhabi. Okay, look, we can integrate this information. Okay, we can create calculations here. Okay, directly on the on this insight. Okay, we can create a delta from the ghost car, because when you have a virtual car, it's really important to calculate the difference between not the position, but the difference in the time on the lap, okay, between the two drivers. Okay, donc we can create a specific calculation here, okay, using this information. Okay, using the millisecond cumulative. Okay, using this information. Okay, you have the median between the milliseconds cumulative and the milliseconds. Okay, directly on this information. Okay, on the lap time. Okay, you can create this function here. Okay, you can create. I need to use my race analysis. No? Yeah. In this, you select your race analysis. Yes. Okay, you can select your race analysis workbook. Some questions? I will check in the chat. Okay, Nacho is responding. Okay, to your questions. Okay, but you can select your race analysis here. Okay, directly, and you can create these functions. Okay. This race analysis you can create for the buses car. Okay, you can create here, add calculations. Add calculations, okay. And you can take for the race. Stop it, stop, stop. For the lap time, not the race. For the lap time, yes. Millisecond cumulative, okay. Yes, you can take the millisecond cumulative here, okay. And you can take use median millisecond cumulative here. Okay, you can create this delta to ghost car. Okay, you can validate your functions. Okay, to be sure. Okay, it's okay, and you can save. Okay, and you have this calculation here. Okay, so the next step is, okay, you can use your delta. Okay, in the visualization. Okay, you can pick the lap. Okay, the lap, the driver reference, and the delta. Okay, you can take here the lap, the driver reference, and your function delta ghost. Okay, pick visualizations. Okay, directly this visualization. And you have all these representations, okay, of these graphical representations here, okay. And you can see, I will move this on the bottom to see better. Okay, you can see the virtual car here, okay. You can see this information when we are the virtual car. Okay, probably in the lab 25, we have this information, okay. The decrease, okay, the difference, okay, the delta to the ghost car, okay, in this case here. okay? You can select, okay, this part if you want. Okay, you have the different point, okay, on this representation. Okay, it is this step, okay, on this part, okay, you have different representations, okay. You can see this information that you can save your here. You can save your workbook, okay. You save your workbook. So probably this it's we have lots of changes, okay, but we can have with a virtual car, okay, we have another behavior, okay, and probably it's really important on my machine learning to use the ghost car, okay, the concept of the ghost car, or the virtual car if you prefer, okay. Donc in the conclusions on this, okay, on this lab 5, okay, the number of opposition recovered by the driver, okay, during the race, it's really interesting, okay. The position changes, okay, for the pit stop, and the presence of the safety car, it's really important of my model, okay. You need to, probably these parameters are really interesting, interesting to integrate like a feature on my machine learning model, okay. Here, on the lab 5. Now we can go to the lab 6, okay. We come back to the autonomous, okay. We'll come back to the autonomous, and we will use a specific functionality on the autonomous, the machine learning user, okay. If you come back to your autonomous here, okay, you can select the first time, okay, my user F1, okay. I need to authorize my user F1, okay, like a machine learning user. So you need to go to your autonomous, okay, to your service console. In this case, you click on the service console to your autonomous. Okay, you have lots of here. Okay, you can see you have lots of monitoring tools. Okay, for your different SQL queries. Okay, and you can monitor here. Okay, you can check your activity, okay, the different activity on your database, your percentage of CPU, okay, you have all this information, okay, you can monitor perfectly your autonomous database, okay, and you have the administrations here, okay, and in the administrations, you need to select administrations, manage Oracle machine learning user. If you click on these tools, okay, you access, okay, to your you connect to your machine learning module, okay, machine learning module on the autonomous database. And now you need to connect like admin here, okay. You need to use admin. You connect with the admin user. Okay, the first step, okay, we have created, okay, if you remember the, I think I have here, okay, if you remember this script, we have created the F1 user, okay, with only the grant data warehouse role, okay? Now, I want to execute some machine learning algorithm embedded in the database, embedded in the autonomous. For this, okay, you need to go to your, you click on the show user, okay? And for the F1, okay, well, in my case, okay, it is like a developer, like a machine learning, but you need to click on this, and you need to put an email address, okay? Put the same email address for your account, okay? If you put the email address here, okay? In the tutorial, we explain this part, okay? Here, you put your email address, okay? If you put the email address and you click on the save, okay? The save button here, okay? You create, okay, your user like a developer, okay? Okay, here I have my F1 user like a developer, okay, and you have your email here, okay. So you can, now the F1 user is not only a data warehouse user, it's a machine learning user too, okay, with a machine learning profile, and I can develop some specific machine learning algorithm inside in the database, okay, here using this user. So you can, the next step, okay, on the tutorial is I want to generate new features, okay, here. Okay, you can click on this button, notebook, to generate feature. Okay, you can download this, sorry, it is not this button. You need to save with the button right, the right button. Okay, you save this link as on your PC, okay, on your download folder. Okay, you save this notebook, okay, you download this notebook. Okay, so you download this notebook, okay, it has JSON format, okay, and we have a specific tool in Autonomous, okay. Now you can go to your Autonomous, you select the development link here on the left bottom, on the left side, okay, and you have here the Oracle Machine Learning user interface. If you select on this machine learning user interface, okay, you connect here with your F1 user. F1 user, okay. And you connect to the module, okay, on Autonomous, a specific module, okay. It is a notebook module to develop your algorithm in Python, in SQL, in multiple languages, okay, here. And you can import, okay, you can go on the left here, notebooks, okay, you can create some project, okay, or you can click on the notebooks here, okay, well, I have different notebooks, the second page, okay, you can click here on import, okay, and you select this JSON, okay. When you select this JSON, okay, you open the, you import this JSON to your notebook, okay, directly here, okay, and you have this notebook, Red Bull Racing generated new features, okay. If you click on this, you edit the notebook server, okay. This interface is similar to Zeppelin interface. If you know Zeppelin, okay, Apache Zeppelin, it's really similar, okay. It's based on Zeppelin, okay, interface. It's not based on Jupyter Lab, okay. It's based on Zeppelin interface, okay. So you have all these notebooks, okay. In this notebook, we have different paragraphs, okay, with a percentage SQL, different query. We are creating some view here, okay. You can see we are creating some view using my insights, okay. I have discovered previously, okay. Now we are in this notebooks, okay. You can click on the bottom here, run all paragraphs, okay. When you have imported this notebook, you click on this run all paragraphs, okay. When you click on this, you execute all the different paragraphs with SQL, okay. Here directly, okay, we create different view, okay. We create, for example, overtaken position total, okay. We create different views, different on the database schema, okay. Here you have the comeback score, okay. The insight we have discovered in the previous lab, okay. Donc we create this specific view on the database, okay, with this script, okay. Donc, you can execute all this, okay, and you have new tables, new views on your data model, okay. And we can execute alter table, okay, on the race, okay, directly here. Okay, or you have all these information, okay, different. You can merge your data, okay. We are executing these notebooks, okay, using the SQL language, okay. I can show you another notebooks, okay. We don't execute today, but in other Ransom lab. Here, okay, I can go, okay. I was checking the different questions. Okay, it's okay. You can go, I will show you, okay, you execute this notebook with all the paragraph, okay. You should create the different new fields, okay, and the different attributes in the database. And at the same time, you are creating lots of views, okay. For example, here, you can use, okay, different, you can use, we have seen in this notebook SQL language, but if you want to execute Python, okay, I can show you, okay, another notebooks, okay, where you can create some Python functions, okay, using the Python interpreters, okay. Here we can see you can execute, okay, some some codes, okay, in Python code, okay, directly on your database, okay. It's a notebook working on this autonomous database, okay. And you can generate some plotter directly, okay, using your Python language, okay. If you like the Python language, you can do the same, okay. You can create some functions, okay, directly here on your database, okay. I will show you in another workshop, okay, this type of functionality. Now we are executing this part, okay. We are executing the notebooks, okay. We are executing these notebooks, the generated feature notebooks, okay. And now, okay, we are using these notebooks to generate until 2019, okay, the race train tables, okay. If you check in your autonomous, okay, here, I can check my autonomous. No, I can go to my database actions. You connect to your database actions, okay, like no, like admin, like F1 user, sign out, sign in, your F1 user, okay, you connect with this user, your data, your autonomous, and you can see in your autonomous, in the SQL, okay, in your F1 user, you have created tables, views, okay, you have lots of view, come back score, okay, like a view, okay, laps with the change positions, okay, overtaken position total, okay, you have created different view with this script, okay, directly on your autonomous. Now the next step, okay, we want to execute, okay, the new features, okay. My next step is I want to execute, okay, the new features. We are creating all these new features, and now the next step is the task 3. I want to train my model, okay. In your autonomous machine learning model here, okay, now this here, you have the AutoML module, okay. Oracle has integrated on the autonomous database, has integrated the AutoML library, okay, the typical library implemented in Python in the last 4 years, okay. And we can execute regressions and classifications, okay, in parallel, different methods, okay, on your for regressions or classification. In my case, okay, here, okay, if you check the task 3, okay, you can create here, okay, you can create new predict race score, okay, I will put race 2, okay. You can create your experiment, okay, for your auto machine learning model. You can choose your tables, okay, here, okay. My table is the races train, okay. You can select the tables, okay. My table, it's races train, okay. Click. You select these tables. It is my train model, okay, my train table, okay. I have created the data set from the Formula One until 2019, okay. You can select here, well, okay, you want to predict the score, the final score, okay, it is my objective. I want to predict my final, score, okay. You select here the regression, so you have the classifications and the regression. In my case, it's a regression, so, okay, I want to predict the score, the final score, okay, and here you can select the race ID, okay. And if you check the tutorial, okay, we have all the attributes, okay, all the different columns of the race train, okay. Okay, if you check in the tutorial, okay, I will show you the additional settings here. Okay, you can change the additional settings for the AutoML algorithm, okay. And here you want to execute, okay, for example, the negative mean absolute error. Okay, you can change, for example, with the mean square error, or the mean absolute error, or the negative median absolute error, okay. In this case, we will use, okay, we will search the best model with a negative mean absolute error, okay? You can execute this, okay? You select the different method, okay? With these regressions, you can execute a GLM, generalized linear model, okay? A ridge regressions, a neural network, okay? Super vector machines, okay? Gaussians and linear models, okay? It is all these 5 methods, okay? For regressions, okay, executing in parallel using AutoML, okay, and we can choose the best model, okay, at the end of this, okay. So you have this integrated on the autonomous database, and now you can select the, okay, circuit ref, DNF count, okay. And if you check, we can select the name here, then select. We take the overtaken positions, okay. The total, no, we don't use the total, okay. We don't use the race count. We take the rank versus positions, okay. We don't use the round. We use the safety car parameter, okay. The score, it is my predictions, okay. And I don't use the time, the URL, okay. It is not an attribute for my model. I'm using the with or weight, okay. I don't use the year and the year. Okay, in this training data set, I'm using all these attributes, okay, to try to use my AutoML regression functions, okay. You save this experiment, okay. Yeah, okay. You have, okay, here in your experiment settings, okay, for this, okay, you have your algorithm, okay, negative mean absolute error, you have all these informations, okay, and you have the different feature, okay, you have selected for this AutoML execution, okay, and now you can execute here the start your experiment, okay, and you have two possibilities, faster results or better accuracy, okay. For the time, okay, we don't have lots of time, we will use the faster results, okay. When you select the faster results, okay, you start your experiment, okay, and you are executing, okay, you can check here, okay, on the right side, okay, you can see we are executing the typical auto machine learning algorithm, okay. We are executing initializations, okay, the different work flow, okay, the algorithm selections, the adaptive sampling, the feature selections, okay, on this step, the model tuning, okay, for the AutoML, we can, when we are using auto machine learning algorithm, okay, we can tune the model, we can tune the different parameters, the different feature on my model, okay, and we are executing all this information, as you can see, okay, directly in the autonomous, we are generating the different model here, okay, we have the different model here, okay, and you have the negative mean absolute error, okay, for the different algorithm, okay, we are with the last algorithm, the neural network, okay, and now, okay, we are tuning, okay, and you should have a button on the top, if I say running, okay, we are in the feature prediction impact, okay. We are executing these 5, okay, models, these 5 methods in parallel, okay, on the autonomous with one CPU, okay, we have selected only one CPU, and it's completed, okay. When you have completed, you have executing on your autonomous, okay, you have completed the state, okay, in 1 minute, okay. We execute these 5 methods in 1 minute, okay, in parallel, and with only one CPU, okay, on this autonomous. Okay, you have executing on the training data set, okay, you have executed this AutoML functions, okay. What is the best model? Okay, what is the best model? Okay, if you check your best model, it should be, okay, if you don't have any error on your machine learning model, okay, it is the generalized linear model, okay, this factor here, okay, it is the best factor. Negative mean absolute error, okay, it is this model, okay. You need to know this information, GLM for FC, okay, for the next step on this answer labs, okay. Here, the next step, okay, we can go back to the autonomous, to the analytics cloud here, okay, we can go back to the analytics, and now I can import the model, okay, to import the model, okay, and I will go back here, okay, you have a specific menu on the right side, okay, here, I will move this, okay, you can register the machine learning model here, okay, you select your connections, okay, and you can select, I want to use, okay, my best model, it's GLM for FC, okay, for FC 14, sorry, GLM for FC 40, it is this model, okay, you select this, regression model, generalized linear models, okay, and you can register this model, okay. Now, my Oracle Analytics Cloud can use this model generating in the database, okay, directly from this interface. So the next step, okay, if you follow the tutorial here, okay, we can go to, well, we have, okay. Yes, the next step is to go to your Analytics Cloud here, okay, you can go back. And you can select you already did the generated method, okay, the generated model, and the next step, okay, is to take your races, okay, you take your data set here, data, races, okay, you open this data, okay, you edit the definitions on the bottom, okay, edit the definitions, and you select, okay, you execute add all, okay, here to add all your different new attributes, okay, directly to your data set, okay, and you click on OK. Now you have imported all the attributes, okay, all the new attributes, all the new features you have generated on your, you click here, okay, directly on this data set, okay. Now you can use your training model, okay. We have imported the registration model, it is the task 5, okay, here, okay, if you check here, okay, it's the task 5, okay, register the machine learning, okay, we have done this task previously, okay, and now you can predict the score for the 2020. How you can create, okay, how you can use autonomous, okay, we have a specific functionality in autonomous. I can design here, okay, a specific data flow, okay, you can create here a data flow, okay, create data flow, and in this data flow, okay, you can create this data flow, you select your races data set, okay, races 2 for me, for your races, okay, you select your races. You have your information here, and what is my objective? I want to use my training model, okay, generating in the autonomous database. I want to use this training model here, okay. And then you select the races, okay. The next type is I want to filter. You select filter, you drag and drop here, okay. You select here, okay, with the year. I want to test my model, okay, on the year 2020. 2020. Yes. If you select this filter, okay, you have on the bottom the 2020, all the races for 2020. Okay, here with a score. Yeah. The next step is to use my model. You can apply here, you have the access to your model. You can drag and drop your model here. Okay, and you can choose your GLM model. Okay, you have imported previously. Okay, you have registered it previously. You select this model. Okay, you have the predictions here. Okay, it is I want to predict. Okay, I'm generating a new column predictions. Okay, for these years. Okay, and after you can select the different column you want to generate on your data set. Okay, you select your column. Okay, you remove all the column. I want only, okay, if you check in the tutorial, race ID, name year, score, and predictions. Okay, and we generate this data set. Okay, and I want to save my data. Okay, my new data set. I click here and save my data set. Okay, and you can create. Okay, directly. I want to generate a new table here. Predicted score. Okay, I will generate with another tables. Okay, in my case, for you it's predicted score. Okay, you create these tables and your data set on your. Okay, and here you need to, you have the measure. Okay, that here it's an attribute. You put attribute for the race ID. Okay, and the score measure sum. Okay, directly here. And you can save your data flow. Okay, you save your data flow. Predicted score. EF. Okay, data frame. Okay, I will put another name for you, for me. Okay, you save the data flow. Okay. Okay. Replace data. Oh, I lost my connection. Okay, I need to log in another time. Okay, I have my data flow. I have creating my data flow, and now you can execute here. Okay, you can click here and you can execute your data flow. Okay, when you execute your data flow, you generate, okay, the new predicting score. Okay, your predictions, that we can compare the prediction with the score. Okay, with this execution. And now if you check on your tables here, okay, on your data, okay, you are generating a new tables. Okay, the predicted score. Okay, you are generating these tables on your autonomous with race ID, name, year, score, and predictions. Okay. Okay, you are executing this score. Okay, so the next step in the labs, okay, is to generate, okay, directly to evaluate the accuracy of your model. Okay. Okay, you can execute. Okay, here you come back. Here, okay, you come back to your data. You select your predicted score. Okay, and you create a workbook with this predicted score. And you can select all this. You can pick, okay, these visualizations that you can compare, okay, directly these information. Okay, score and predictions here, and race ID and name here. And you have the results, okay, that Jeroen has presented at the beginning of this workshop. Okay, you can compare the predicted score for 2020, okay, with the predictions of your model. Okay, we have some good predictions, okay, and some little difference between the predictions in my model, okay, and the score, the real score. Yes, is it okay? I will save my workbook now, okay. Predictions, okay. I can save my workbook and I have the results of this workshop. Okay, you can do the same, okay. We can apply the same model for 2021. Okay, we have the data set with the 2021. If you want, okay, you can do the same, okay, on your at home. Okay, I can show you some results. Okay, for example, okay, in my workbook, I have generating, okay, here, okay, my prediction. I will show you, for example, in the new tab. For 2020 and 2021, okay, you can generate, okay, you can apply the same models. It was the result for 2020 here, okay, and for 2021, okay, I have another result, okay. And for example, here, if you check the data set, okay, you can check here, I have a bad result here between, and it was a specific race, okay, for the last year for the Belgian Grand Prix, because it was a weight Grand Prix, and they did not do the race, okay, in this Belgian. It is the reason, okay, my prediction is not good. I need to delete this Grand Prix, okay, in my data set. Okay, conclusions. I will show you now. Okay, the conclusions. We have seen, okay, the different predictions you can execute. Okay, you have the data set to execute and to compare the final score for 2021. Okay, I will stop share.
Thank you, Olivier, for the fantastic demonstration. So as I briefly mentioned earlier, we would like to test your knowledge on what you learned today. So by completing several questions of our lab quiz correctly, you'll achieve a social badge, which you can share on your social media. And then lastly, if you enjoyed today's session, we'd also like to invite you to check out our upcoming events or our previous recorded labs here. So I will be dropping these links in both the chat and the Slack shortly. And we also encourage you to share with us any feedback that you have on today's session or on what you'd like to see from us going forward. So let me go ahead and drop those links right now. So with that, I'll go ahead and end today's session. Have a great day, and we hope to see you again next time.